So yeah, simultaneous equations mentioned on paper 3. However, as we know, not all simultaneous equations are created equal. So these are sort of basic simultaneous equation questions. So Finn, talk me through how you started the first one.
Will do. I multiplied the top one by 6.
Okay, so Finn decided to get the same number of y's, so he left the second equation as it was and multiplied the top equation by 2. Not the only way of doing it though. Did anyone go with times by 2 and times by 3 to get 6x's? We should get the same answer. We should get the same answer. So, and I have to say, I tend to always try and get this the same, just because that's the way I'm used to it, but Finn's way is actually, in this case, a little bit easier. So we then ask what's changed, and we can go either way, but we tend to go from the variable that we haven't got the same as, in this case it's the x's, we go from the fewest to the most. Katie and Amy, Amber, are you with me? So I'm going to go that way. Going from here to here, I'm adding 4 x's, but that has the effect of making the 2 become a minus 10. So adding those 4 x's makes the total 12 small, so that means x has to be minus 3. You then rewrite either equation. Which one did you use, Finn?
2.
So it doesn't matter which one, we should get the same answer. So 2 lots of x, well that's minus 6. Ugh. Right, I'm going to add add 6 to both sides. Okay, yeah, I'm just going to add 6 to both sides. If you added 4y, yeah, that's good. 2 add 6 is 8, and I'm going to divide by minus 4. So that gives me that x is minus 3, y is minus 2. Yeah, which works. And if you've done what George did, same answer. Okay. So Callum, how did you start the second one?
You can either times the bottom one by 5 or the top one by 3 and the bottom by minus 1.
Yeah, so you've just got to be aware, if you choose to multiply this one by 3, you've got to use minus 3 or multiply the bottom one by minus 1 because you need the same number of y's. Plus 3 and minus 3 is not the same. Hello?
Mr. Ward, have a whiteboard pen.
A whiteboard pen, certainly. So I'm going to do what Callum suggested first and multiply the second equation by 5. Just make sure you multiply it all by 5. And then what's changed? Fewest to most, so that's going that way. From minus 15y to plus 15 to plus 1y, 16y's. It's made the total smaller again, hasn't it? Have I done that right?
Can you do the arrow the other way? Wait, no.
Yeah, no, I'm just checking I've multiplied by the right. Yeah, you can do that. So from 45 to 21, I've got 24 smaller. That's not very nice, is it? So y is 1.5 or 3 over 2. Well, I know what I'm doing. I'm going to go into the first equation. So 5x plus 1.5 is 21. So 5x is, take away 1.5, 19.5.
3.9.
Say again?
3.9.
Thank you. And actually it says non-calculator, but we don't need to worry about that because we are told that simultaneous equations will be on paper 3. And those are simultaneous equations. We call those linear simultaneous equations because the two equations, if we plotted them on the graph, would be straight lines. And then we can tell they're linear because we've got no powers of x. So these are also simultaneous equations. These are also simultaneous equations. But these are not nice because they are no longer linear. Actually, this is the equation of a circle. I can't even call them quadratic simultaneous equations because I've got something here which isn't even a quadratic. It hasn't just got x squared, it's got x squared and y squared. But we still need a method for this. So we're going to revise this today. We're going to do a number of these. I'm going to work through the first one with you, and then you're on your own. So with these more complicated simultaneous equations, the first thing to do is to recognise that there's always going to be a simpler equation and a more complicated equation. Okay? So there's always going to be one which is a bit more simple. And generally that will be a linear equation. I'm being careful because famous last words, they might throw a curveball at us, but no, I think that we've got, in this case, fairly obviously, this is the easy equation. So I'm going to spot the easy equation, or the easier equation. And I'm going to rearrange it as either y equals something or x equals something. And I can choose. But I'm not stupid. So I'll be stupid in this one to rearrange this as x equals, because I'd have to divide by 3 at some point. And 13 divided by 3, well, you know, that's not very pleasant. So in this case, I'm much more sensible to rearrange that that second equation as so I've rearranged the easier equation in this case as y equals. And then all I do is I rewrite the more complicated equation, replacing either x or y, in this case y, with what I've just found out y is equal to. So I have rearranged my simpler equation as y equals. So I'm going to rewrite my more complicated equation, but I'm going to replace the y with 13 plus 3x. So it becomes x squared plus 13 plus 3x squared equals 25. And remember what we talked about last lesson. This is not 169 plus 9x squared. I've got to grid that out. So can I get you to grid that out for me? 13 squared is 169. And then can you line it up? We'll ignore the minus sign, the no calculator sign, because we know. Can you, once you've expanded it and written it all out, can you line it up with a 0 on the right hand side? So you're going to multiply out the bracket, and away you go.
So what's 13 squared again?
160. Now you probably remember that in some magical cases, one of the equations is already written as y equals. So we don't need to do that step at all. And in some miraculously easy examples, they're both written as y equals. So we can just replace the y in the more complicated equation with y. the simple equation tells us y equals. So you should realise that you've got a quadratic equation to solve. So if you're ahead of me, by all means.
So we're just doing these orders.
Well, yeah, look, you've got a printout of what I've got here. 3x times 3x, remember it's 9x squared, 3 times 3, x times x.
Where did you get the equals 25 bit from? So
That
you
was
kind of
that was
included
there in
there.
the original equation.
Yeah.
Oh, I hope this was going to simplify a bit nicer than that.
So it's 169 takes 25, not 144.
Oh, oh, that's still. Thank you. That does help me a little bit, doesn't it? Let's get. Were you going to tell me the same? So I've got what's that? 5x squared equals 39x plus 50 plus 22, 72. Ooh. Okay, never mind. I mean, it probably will factorise. It probably, well, no, because we know it's going to be on paper 3, so we can ignore ignore. We probably will be able to factorise this, but let's pretend that we can't. So let's use the formula to solve this one, and I'll get my calculators out. So the formula will be on the formula sheet. Remember, it's the answers are minus b plus or minus b squared minus, I always put 4ac in brackets, over 2a, and in this case I've divided everything by 2 because 0 is your friend. A is 5, b is 39, c is 72. Some calculators out. Who would like to borrow a calculator?
Wow.
So how much would this be worth?
What are we talking about? That calculator?
How many marks?
Oh, how many marks? Good question. I took the number of marks out. They're 4 or 5, I think.
Oh,
But it'd be quite high end in the paper. You'd
Yeah,
probably like
yeah.
grade 7 or 8
Yeah.
kind of guy. And how do you make them the same? How do you make them the same? Yeah, like why are they square? Never noticed. That doesn't make sense.
So it's like that. No, so you know how this one
Yeah.
You had yeah, so it's this one.
Yeah.
So you ignore the hard one, and then you got this one, and y equals 13 plus 3x. You just rearrange this one to get y equals.
Oh yeah, 13 plus 3.
And then you substitute it back into this one to get that was not 5 squared, which is 5.
So talk me first to
Come on.
Sorry?
No, I'm doing.
So what would you
No,
do?
I said, who wants a calculator? And you were silent.
You sure?
And then you can write it as x squared. And then in brackets, y dash.
So it would have factorised, some of you might have factorised it. It's probably. Oh, there's a big sign. There's a big
That
sign.
equals y something. So you know that's y first. So that's what y equals, yeah?
Yeah.
And it's asking for y squared, so it's just that in the square root equals 25.
So that's why we're good at that.
Everyone's doing no idea. Everyone guys.
What are you going to say? So if I ask you, why do you want to join Petra? Why do you want to go to Petra?
They're trying to
Okay, so I've got my my x values, but we've got to remember that this is a problem with y and x. And what we're doing here, if you remember, is we're saying there's lots of x and y values that make that first equation work, and there's lots of x and y values that make that second equation work, but there's only one pair of values that, there are two pairs of values that make both equations work at the same time. And so we've got two x values, we also need y values. Have I got a way of working out y if I know what x is? Well, yes. That was what I did right back at step 2, wasn't I? Y, if x is minus 3, y is equal to 13 plus 3 lots of that.
How many marks is that?
Be a lot. So that's one pair of values. Y is minus 3, x is minus 3, y is 4. Important that you make it clear those two are together. And then if x is minus 4.8, y will be 13 minus 3 lots of 4.8. So that's 13 minus 14.4, which is minus 1.4. That's another pair of values. So, a tricky question, but as I so often say, you must be able to get at least a mark, surely, just by rearranging the simple equation as either x equals or y equals. Maybe 2 marks by substituting that in and getting to here. And then another couple, or maybe even 3 marks for getting it to the end. But yeah, marks up for grabs in every case. So you've got a set of questions and you've got the mark scheme. Don't be put off if the mark scheme does it differently to you, as long as you've got the same answers. And to those of you watching at home, I will attach a copy of the questions and the solutions to the email where I send it to you, as well as linking it in the description below, and you can work through them yourself. All right?
The description below.